Hey everybody, this is Larry. This is me going with Q4 of the weekly contest to reach 29. Minimum cost to split an array. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. This is a very standard to read dynamic programming problem. I think this is kind of a little bit hard, to be honest, initially. But I think the key part about these problems is try to figure out what are the constraints that you're working with, meaning that literally, well, what are the constraints? And here, the first thing I did was I saw 1,000, and that says to me that 1,000 squares is possible, and from that, it means that you can kind of, and this is just from experience. So definitely, if you struggle with this problem, work with a lot of dynamic programming problems. But that means that you can not brute force, but you could try every possibility on a suffix solution, right? Meaning that if your subproblems are suffix of the solution, then you can brute force on them. And what I mean by that, well, we'll go over in a sec. But that means that here, and what I mean by suffix subproblems is that for here, that we can try to figure out the best solution for this suffix, and then this suffix, and then this suffix, and this suffix, right, and so forth, and then a way that we can combine them in a non-constant way is fine, meaning it takes linear time to combine them, and then that will give you n squared. And we'll talk about the solution here. And to be honest, there is this idea, this concept, which is sometimes a little bit tricky for sure, is that this idea that you're kind of almost like a rowing type of solution. And what I mean by that is that, well, let's go over it, right? So basically I have this thing, as I said, this is going to be the min cost of num sub index to the n, right? So this is equivalent to just returning this as the function, meaning the suffix from index on. And of course, if there are no more elements, you return 0. Otherwise, you have to basically have this rolling counter that goes from left to right, and it's very order specific, that allow us to do two things at once, right? So, and what I mean by that is that naively, another way you can think about it, and like maybe the first, if you haven't practiced a lot of dynamic programming problems, and this is actually not, it's kind of a more of an intermediate to advanced thing to do on a dynamic programming problem, but there's just been a lot of Leetcode problems that kind of makes it, people have more practice on it for sure, but I wouldn't say that this is an easy leap to make. Maybe another way to write this, if you're a beginner or if you're just delving into dynamic programming, you may write something like this, right? Same idea, but here maybe you do something like C is equal to collections.counter of num sub index to n or something like this, right? And this basically just now, and then everything else is the same, right? Let's say, and then here you just do maybe do a for loop on the counter, like for x is in c dot values. If x is greater than 2, meaning that if they're duplicates, then cost is adds x, and then now, so here cost would be 0 here maybe, right? And this is and then best is equal to min of best cost plus k plus go sub I plus 1. So same thing up to that point, but here maybe this is the first iteration of how you would think about it, is that this will obviously take linear time on top of this. So then now that means that this function will take n squared time, right? Because you have a linear for loop, and then you have a linear cost operation. So the idea here is kind of a sort of unrolling this loop so that you can build this C in, but you could build this C incrementally and then build the cost incrementally. That's basically the idea here, that gets so that this doesn't have this O of n operation. And basically what you do here is, I hope I didn't delete too many things, but basically you start with cost is equal to 0, and then you keep a counter that goes from left to right, and basically if it hits 2, you add 2 to the cost, otherwise you add 1 to the cost, and this is just how you do it incrementally, right? with the n, and then you basically do recursion on that. And of course, with dynamic programming, this is basically the idea. And I'm going about this a little bit fast, I admit, but and of course k is the input cost that's here. But yeah, but this is a way from this point on, kind of a standard partition suffix dynamic programming problem. And here, the way that I always say it is that index can go from 0 to n, of course, and each input takes O of n time. There are n inputs, so total time is going to be O of n squared, which for n is equal to 1,000 should be fast enough. And of course, total space is also going to be maybe O of n, depending on how you want to count the intermediate thing, because at the peak it's technically, I don't know, maybe n squared, depending on how you want to say it. But yeah, and of course you can write it this bottom up. Yeah, that's all I have for this one. Let me know what you think. This is not, again, the reduction from what I had before, the n cubed one to n squared one, is actually not that easy. So definitely, take a time to kind of see, what I had. Oops, I guess I can't bring it back that easily. But yeah, maybe go back and rewind it and kind of see that code. And this is, and that kind of code, maybe with your unfamiliar or unpracticed, you may write that first and you'll be like, okay, now that I have this code, how can I, make this slightly faster, right? And that would be maybe the idea. And this is the idea rather, to build it incrementally, and because all we need to get down to is n squared to be fast enough. Cool. That's all I have for this one. I think the only part that maybe I didn't explain that much is that, because if this is only 1, it doesn't do anything. Otherwise, if it becomes 2, then we have to count both of them for the first time, and then just one more for this, which kind of matches the stripping of solo things. But yeah, so this poem I actually do like a little bit. It's a little bit of a twist, and even though it does have a little bit of a tricky thing that you just have to know how to do. But yeah, I actually think I solved this one faster than Q3, so I don't know. Cool. That's what I have for this one. Let me know what you think, and you could watch me solve it live during the contest. Now, spent so long proving on that one, to be honest. Like, I knew that one a little bit, but I just didn't prove it. All right, focus. Finish this problem. Where am I at? I guess it's not 10 minutes yet. I don't know how they do the virtual thing. Oh, people are already done, which is not surprising. The Q3 was hard. People got it very quickly. Well, I mean, it's not that hard. It's just hard to prove for me. All right. The cost of a split is the important values of each subarray in the split. What does that mean? Split. Okay. Split an array into some numbers of non-empty subarrays. Cost of a split is the important values of each. What is important? Let trim be the version. What? So much weed. But a lot of people got this one, which I'm cheating by looking. But okay. People only ones are removed. Okay, so you only get the dupes or numbers with dupes. Okay. Important one is k plus the length of this. So trim this equal to why would be k plus 5. So you're just given k. So with 0 plus 2, okay. And we're trying to minimize. Okay. N is 1,000. Are we DPing? How would I DP? I mean, it's probably DP. People got really quickly, actually. I actually wasn't that fast on, I mean, I was fast on the first 2, but not the Q3. Because I just had doubts, even though I wasn't that bad, but I mean, it's got to be DP, right? But can I do it in a good way? Do I need to do it in a good way? Can I do something like this? And this may time out because this is Python, and if that's the case, I blame Leetcode because this is pretty intuitive way of writing it, maybe. But I could apply also, to be honest, be a little bit less dumb about it. Okay, right. And then maybe like see like. It's now you go to 2. One plus. It's really awkward. How do I do the dupe thing? Okay, so if it's equal to 2, then cost is equal to 2. Else if something like that maybe, and then we do a recursion on I plus 1, and then cost plus this, and then best is equal to min. I probably could have written this tops down, but bottoms up rather. Plus k, right? Yeah, this is I see how this could be a 2-minute problem. Well, maybe more if I actually got this right, but. Oh, it's a min. I am dummy Larry. 8610. Alright. This may time out, but it's right. Whether it's timeout, it's based on Leetcode. This is just a guess, right? Like we can rewrite this bottoms up. Okay. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this video, and the contest and everything. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.